Hello and welcome to another class of environmental science. Today we will study environmental degradation. So here we will study global warming and climate change, ozone depletion, desertification and land degradation, pollution and water stress. So let us study one by one. So first is the climate change and global warming. So what is climate change? Climate change is just change of climate which is attributed directly or indirectly to human activity. So change in the normal composition of climate, it is called the climate change. Clear? So next, we will see what are the causes. One is the Milankovitch cycle. This is the Milankovitch cycle. It causes a variation in the amount of insolation received as well as the intensity of insolation. Then solar cycle, which changes after every 11 years. Then plate movements impact heat distribution on the earth. El Nino and related phenomenon. Then meteorite impact, as we have seen millions of years ago. Then large scale volcanic eruption. Recently also, recently at a volcano which is assumed to create pollution in Delhi and nearby areas. Next, anthropogenic causes. So what are the man-made causes? One is the large scale release of greenhouse gases causing global warming. We will study what is greenhouse gas, burning of fossil fuels, agriculture and industrial emissions, changes in land use pattern like deforestation, urbanization release like chloroform, CFCs, HFCs, etc. And also from the agriculture sector, release of methane. And then what is global warming and greenhouse gas? Global warming is a situation in which the outgoing terrestrial radiation is trapped in the atmosphere. Generally, আমি কি দেখা পাও? The incoming solar radiation, then suppose 100% আহিলে and 80% is passed and a little bit of energy, sunlight or energy ইয়াতে থাকি যায়. But now because of global warming, because of greenhouse effect, because of use of greenhouse gases, what happens? More amount of heat is being trapped in the atmosphere, causing global warming. So this is global warming and this is caused by greenhouse gases. So let us study. So greenhouse effect in general is a natural effect. However, excessive release of greenhouse gas has increased the impact of greenhouse emission, resulting in global warming. Clear? Normally heat trapping is very much normal, but now what happened? Because of excessive release of greenhouse gas, more amount of heat is being trapped, leading to global warming. So what are the greenhouse gas? Ekita monot rakhibo ha, examot ahe. Carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, sulfur hexachloride. These are under Kyoto Protocol. Then water vapor, black carbon and chlorofluorocarbon. Clear? Next, let us see what is global warming potential. It is a measure of how much energy the emission of 1 ton of a gas will absorb over a given period of time relative to emission of 1 ton of carbon dioxide. Mane 1 ton of carbon dioxide or comparison of 1 ton of carbon dioxide or comparison of how much energy it will release. So next we will see the table. Next, atmospheric lifetime. We have what is atmospheric lifetime? মানে atmosphere আজি যদি রিলিজ করে atmosphere কিমান টাইম থাকিব, time period up to which greenhouse gas stays in the atmosphere. Carbon dioxide, what is the atmospheric lifetime? 50 to 200 years. What is the sources? Burning of fossil fuel, deforestation, etc. This is a very important table. এখনৰ পৰা questions খুব সঘনাই দেখা যায়, kindly এখন ভালকে পঢ়িব. Methane, what is the atmospheric lifetime? 12 plus minus 3. Global warming potential মানে কার্বন ডাইঅক্সাইডৰ তুলনাত কিমান বেছি এনার্জি রিলিজ কৰে? This is 21. ক'ৰ পৰা আমি মিথেন পাওঁ? মিথেন এমিশন ক'ৰ পৰা হয়? Growing paddy, excreta of cattle and other livestock, termites, burning of fossil fuels, wood, landfills, etc. Then nitrous oxide, atmospheric lifetime is 120 and global warming potential is 310. Burning of fossil fuels, fertilizers, burning of crop residue, etc. Then hydrofluorocarbons, atmospheric lifetime 1.5 to 209. Global warming potential 150 to 11,700. Primarily produced for use in refrigeration, air conditioning, insulating foams, etc. Then perfluorocarbons 2,600 to 50,000. Global warming potential of 6,500 to 9,200. Mainly from the aluminium smelting industry has been a major source of atmospheric perfluorocarbons. Then sulfur hexafluoride, atmospheric lifetime of 3,200 and global warming potential of 20,900. SFC is a substance which originates only from anthropogenic sources, primarily from semiconductor industries where it is used as electronic insulator due to its inertness. So let us see how the greenhouse gases warms our planet. Mainly highest warming core hoy, the one having highest global warming potential and living the highest time. So the fluorinated gases, the global warming potential of fluorinated gases is much more. So they warm the planet much more. But in practice we do not see fluorinated gases as they are mostly eliminated. So atmosphere ki poa jay. 76% of our atmosphere is filled with carbon dioxide. Then methane 16%, nitrous oxide 6% and fluorinated gas 2%. So any kind of gas, how it affects depends on three things: how much of the gas exists in the atmosphere, atmospheric lifeline and global warming potential. So these three decides how it will impact on global warming. Clear? Next, let us see ozone depletion. So what is ozone depletion? So in the UV radiation, as we see from sunlight, there comes the UV radiation. We have three kinds of UV: UVC, UVB and UVA. UVC is the most dangerous and 100% is filtered out in stratosphere. Then UVB, 90% is filtered out. Prolonged exposure may cause skin cancer and UVB is also a source of vitamin D. And UVA, it is not harmful, 5% is only filtered out. So what is ozone? Ozone is the allotrope of oxygen. So single O, jodi single jodi amar oxygen thake, then is the least stable. O2 stable and O3 is the less stable. So what we see, O3 jeta thake, it will always tend to form O2 because stability phale ahibo. Clear? So ami ki dekha pao, few of the gases, ozone depleting substances boli kobo ami ODS, few of the gases they will react with O3 in the atmosphere, upper atmosphere O3 lo react koribo and they will form O2, breaking the layer, ozone layer to komai anibo. This is what is called ozone depletion. So what are those gases? Mainly chlorine, bromine, nitrogen are the ozone depleting substances. Clear? So what is it? Continuously converting O3 into O2. Normally needed UV radiation, but now because of ozone depleting substances, it is done without UV radiation. So UV reaches the earth and thus UVB, junto amar risky hoy, cause of skin cancer, it will reach the earth. So this is what is ozone depletion. Ozone layer amar komi ahibo. Clear? So what are the potential drivers of ozone hole over Antarctica? Let us see. Change in Antarctic polar vortex. Polar vortex ki hoy are stratospheric wind patterns. Enekwa polar vortex and stratospheric wind patterns hoy over low pressure and very cold air, more pronounced over south poles, mainly pronounced over south poles, Antarctic, leading to formation of polar stratoscopic clouds. Clear? How they can destroy? They can destroy ozone by providing a surface that converts chlorine into reactive ozone. Clear? Mainly surface area provide kore. Then similarly, as we have discussed, volcanic eruption can also destroy ozone layer. Next, let us come to pollution. What is pollution? Any undesirable change in physical, chemical or biological characteristics of air, land or soil is called pollution. First, let us study air pollution. So first is the type of pollutants. On the basis of nature of decomposition, how it is classified: biodegradable, decomposable or non-persistent pollutants. These substances can be easily broken down by biological or microbial agents. Example domestic sewage. Then slowly degradable কি হ'ব পাৰে DDT or pesticides. Then bio non-degradable or non-decomposable, what it can be heavy metals like lead, mercury, etc. They are non-decomposable. Based on physical properties, what we see, solid, liquid or gaseous. Based on the form of pollutants in which they exist, they may exist as primary pollutant. Primary pollutant is the one which is released or emitted directly from the source. Secondary pollutant is the one, example কি হ'ব পাৰে primary pollutant or nitrogen oxide, sulfur oxide directly released from the source. Secondary pollutant is the one, the substances generated from the chemical reaction of primary pollutant after release in the atmosphere. Clear? Example peroxyacetyl nitrate. Then based on the existence in the nature of pollutants, one is the qualitative pollutant. They do not occur in nature but are generated by man. Naturally occur nokore like DDT, pesticides, etc. Then quantitative pollutants, substances are present in nature and pollute the environment beyond certain levels. Like naturally they are present, but when they are present beyond certain levels, if they exceed hoye jay, they harm the atmosphere. Like carbon dioxide, nitrogen oxide, they are naturally present, but because of the presence beyond certain limit, they harm the atmosphere. Based on the origin of pollutants, natural, the one present naturally, like natural fires. Anthropogenic কি হয়, pollution caused by humans, pollution of air, water, land. Then this table is very much important. Let us see what is it. Sulfur dioxide কৰ পৰা হয়, mainly from burning of fossil fuels, pelting of metallic ores, etc. And sulfur dioxide পৰা কি হয়, chlorosis, loss of chlorophyll. Then in human being, irritation of eyes, discoloration of buildings, etc. Then carbon monoxide, what is the residence time? Residence time is 3 years. কৰ পৰা release হয়, automobiles, cigarette smoking, indoor heating system, etc. What it does, it combines with hemoglobin and forms carboxyhemoglobin and impairs the oxygen carrying capacity of blood, leading to headache, dizziness, blurred vision, breathlessness, etc. Then carbon dioxide, combustion of fossil fuels, greenhouse effect in the air, concentration by heat trap, global warming, climate change, এইবোৰৰ পৰা we release it get released of carbon dioxide, and these are the impact of carbon dioxide. Clear? Oxides of nitrogen কৰ পৰা ওলাই, mainly from automobiles, electric power plants, etc. So what it causes? It causes acid rain, leading to narcosis, defoliation, death of plants, etc. It also forms peroxyacetyl nitrate. Clear? Then organic gases like hydrocarbons কৰ পৰা হয়, benzene from cigarettes, petroleum, etc. They contribute to photochemical smog, refineries, photochemical plants, etc. Then aldehydes পৰা কি হয়, কৰ পৰা release হয়, mainly from incomplete combustion of fossil fuels. They are the precursors of very harmful substances such as peroxyl nitrate. Clear? Then particulate pollutants. What are particulate pollutants? These atmospheric substances that are not gases are referred to as particulates. They are suspended droplets, solid particles, or mixture of the two. First is the aerosols, airborne suspension that are either liquid or solid, coming from vehicular exhaust, factory smoke, etc. Then smoke, dust, grit, small loose particles of stone, soot. Soot is a fine carbon powder, fume, fine solid particles. So these are the particulate pollutants. Then next, let us see secondary pollutants. What are secondary pollutants? One is the ozone, formed by oxygen in the presence of sunlight. What is the effect? Effects warming, affects photosynthesis, respiration, etc. Then next is smog. Smog is there are two types of smog. One is the photochemical smog, fog plus smog, fog plus smoke. It is the smog. So there are two types of smog. One is the photochemical or Los Angeles smog, other is the classical smog. Well, how photochemical smog is formed? Peroxyacetyl nitrate plus hydrocarbons in the presence of sunlight forms peroxyacetyl nitrate aldehydes plus and O3. This is smog. How it impact? It impacts corrosion of metals, reduces visibility, etc. Classical smog formed when high concentration of sulfur dioxide and particulate matter is formed. Is produced due to combustion of fuels. So classical smog ki hoy sulfur dioxide or yate peroxyacetyl nitrate. Clear? Then third is the acid rain. Sulfur dioxide or nitrous oxide plus H2O forms HNO3 plus H2SO4. Impacts corrosion of metals, infrastructure loss, etc. Then there are few minor pollutants like lead, cadmium, nickel, then mercury. Clear? Korpra hoy and what are the associated issues? Kindly ever পঢ়ি লব. Clear? Next we see what are the different kind of indices which measure this pollution. One is the SAFER, that is System of Air Quality and Weather Forecasting and Research. Next is NAQS, National Ambient Air Quality Standards, and lastly it is the Air Quality Index. So who introduced this SAFER? SAFER is introduced by Ministry of Earth Sciences, very important. NAQS notified by Central Pollution Control Board, and AQI initiated by Ministry of Environment, Forest and Climate Change under Swachh Bharat Abhiyan. So what it does? SAFER mainly is a location specific information on air quality and near real time is forecast 1 to 3 days in advance in major metropolitan cities of India. And NAQS, what is NAQS? NAQS are the standards, serve as the guidelines for monitoring and controlling air pollution. Clear? And AQI, there are 6 AQI categories: air quality index, good, satisfactory, moderate, etc. Clear? The very important thing here is the what are the pollutants that are measured. So kiki pollutants measure hoy PM1, 2.5, PM10, ozone, carbon monoxide, NOx, that is NO or NO2, SO2, methane, non-methane hydrocarbons, VOCs, benzene and mercury. These are very important. Suppose yete amar yete CO2 nai. So then what NAQS measures? Sulfur dioxide, nitrogen dioxide, PM10 2.5, ozone, lead, carbon monoxide, ammonia, benzene, benzopyrene, arsenic and nickel. Then AQI key measure kore measures 8 major pollutants: particulate matter 10 and 2.5, nitrogen dioxide, sulfur dioxide, ozone, carbon monoxide, ammonia and lead. Clear? Next, let us see water pollution. What is water pollution? Undesirable changes in the quality of water through addition of undesirable substances or undesirable levels of already existing compounds. Undesirable changes in the water. So we have two sources of water pollution. One is the point source and one is the non-point source. Point source means ki hoy? The area point where the sources can be easily identifiable. And what are non-point sources? There is no single identifiable source of origin. Enters the water body at specific location and it can be tracked in point sources. But in non-point sources, it is difficult to control. I mean, point sources examples how ki hobo industrial discharge, municipal sewage. They come from one point. But agriculture discharge here, if it is a river and this is a field, it can go from any area. This is a non-point source. So what are the important water pollutants? One is the mercury. It can go under biomagnification. What is biomagnification? We will study next. And one thing to remember, there is no safe level of mercury. A little bit of mercury, okono jodi amar mercury body penetrate hoy, it is very much harmful for us. Sources ki hoy? Mining, coal power plants, etc. And what is the effect? Dropsy, Minamata disease. Clear? Then lead. Korpra ahe pawami mining, petrochemicals, creating issues like learning disability, dyslexia, etc. Cadmium. What are sources? So is a battery, mainly from batteries. Effect Ita disease or ouch disease. Clear? Arsenic. Korpra mainly from excessive extraction of groundwater and mining. What it causes? Blackfoot disease. Fluoride. Excess extraction of groundwater. Effect teeth deformation, neuromuscular disorder, etc. Nitrate. Sources: agriculture runoff, industries, etc. Impact What is the impact? It causes blue baby syndrome. Then iron, mining and leaching, mainly from mining and leaching, affect skin disease. Uranium, কৰ পৰা পাওঁ আমি? Mining, affect carcinogenic, kidney disease, etc. Then chromium, source, mining, effect, allergies. Clear? Remember this. Then let us see three terms: dissolved oxygen, biochemical oxygen demand, and chemical oxygen demand. What is dissolved oxygen? Dissolved oxygen is the amount of oxygen, water dissolved in the amount of water dissolved in amount of oxygen. So it is full amount of oxygen dissolved in water is called the dissolved oxygen. It is measured as milligram per liter. So কি হয়, যিমান অক্সিজেন বেছি থাকিব সিমানে aquatic organisms can use it and they will have a better survivability. Then what is biochemical oxygen demand? It represents the amount of oxygen consumed by bacteria and other microorganisms as they decompose organic matter under aerobic condition. Clear? Then what is chemical oxygen demand? It is the amount of oxygen that is required to break down organic substances chemically and convert them into carbon dioxide and water. So the oxygen, আমি যদি চাওঁ BOD and COD difference, BOD is the one used for converting all organic matter. Sorry, the BOD is the one which is used for consumption of biological degradation is the BOD, and while conversion of all organic matter is the COD. So more the amount of oxygen required to break down, that means more amount of pollutant is present. So more amount of BOD and COD is harmful for the water body. Clear? So CPCB considers less than 3 milligram per liter as an indicator of healthy river. Clear? Next, what is eutrophication? Enrichment of water bodies with nutrients is called eutrophication. আমি দেখা পাওঁ ন কিছুমান river or pond there ওপৰত green layer এটা হৈ যায়. So this is the eutrophication. Clear? Next, harmful algal bloom. It is similar to eutrophication. Well, algae is growing rapidly in the water body. It is due to excessive eutrophication along with thermal pollution also. Clear? Then bioaccumulation and biomagnification. What is bioaccumulation? It is a process through which concentration of certain chemical substances increases continuously in the body tissue of organism. Like, suppose this is a river and it is polluted by, suppose mercury pollution ase in this river. Then fishes consume this water from the river. So what will have? They will also have traces of mercury. So this is called bioaccumulation. Now this fish will be consumed by large fish. This large fish will be consumed by human being. So now human being will also have mercury concentration. So this is called biomagnification or amplification. Clear? This is what bioaccumulation and biomagnification. So what are laws and policies controlling water pollution? One is the Water Prevention Control Pollution Act 1974, National River Conservation Plan, National Water Monitoring Program, Namami Gange Program, National Water Policy. Then budget কিছুমান কথা লিখা আছে 1920. Then Water Prevention Control Pollution Amendment Act 2024. Clear? These are the laws and policies controlling water pollution. Next up we have marine pollution. In marine pollution দুটা বস্তু খুব ইম্পর্টেন্ট. One is the Marpol Convention. কি করে? It is a convention covering the marine pollution, and one is the Global Program of Action for Protection of Marine Environment. Clear? Remember this too. And noise pollution. আমি কি মনত ৰাখিব লাগিব noise pollution? Industrial areas or কাৰণে how much decibel is allowed? It is a 75 decibel for daytime and 70 decibel at the night. For commercial areas 65 decibel and 55 decibel during day and night respectively. Residential areas 55 and 45 decibel day and night respectively. And এবাৰ এইখন ফিগাৰলৈ আমি যদি চাওঁ কিমান সাউন্ড হয়, যদি জেট প্লেন ফ্লাইজ ইট ইজ 110, dance club, music club 100, motorcycle 100 decibel, commercial area 70 to 60, heavy traffic 60. So ever just broad idea eta lole hol from this figure. You don't no need to learn, just learn these regulations. Clear? Next, let us see what is water stress. So this figure is very much important. Agote keibabaru UPSC to ahi goise. So mainly amar total water kiman ase 100%. Tare mainly 96.5% is under oceans. The remaining যোনখিনি আছে তাৰ পৰা আমি যদি চাও remaining 3.5%, tare 2.5% is fresh water and the other is saline groundwater and saline lake water. Clear? Then of the remaining 2.5% fresh water, 30% is groundwater and remaining 68.6% is polar ice. Clear? Then out of the groundwater, out of the remaining 30.1 or 68.6 or remaining যোনখিনি এৰিয়া আছে তাতে আমি কি পাও other ice and snow 0.97%, lakes 0.26%, soil moisture 0.04%, atmospheric water 0.037%, marshes 0.33%, rivers 0.006% and biological water 0.003%. Clear? So remember this agote questions ahise yar pra mainly from lakes and rivers. Clear? So how water is stressed, we are water stressed or not, how it is measured? It is measured mainly through an indicator called Falkenmark indicator. Falkenmark indicator. Clear? Next, let us see the timeline of water policy in India. In 2000, Supreme Court decided right to water is a fundamental right. In 2012, national water policy was revamped. In 2014, we have the DDU GKY. Clear? Then in 2015, Prime Minister Kisi Sampada Yojana. 2017, Model Groundwater Bill was formed. In 2018, India and Israel water partnership was formalized, and in 2019, Ministry of Jal Shakti was established. So this is a water policy timeline in India. And also remember Mihir Shah committee, this is related to water policy in India. Clear? আমি যদি চাও one thing getting in news, there is a traditional water conservation techniques. What are traditional water conservation techniques? Like for example, dongs in Assam, mainly I guess it is by a community, Boro community, Boro or missing. Okay, Jebo, then Jinx, Cools, Nola. This is a question ki ahibo pare, states di dibo pare, states may be given along with the traditional water harvesting techniques. Clear? So this is the water harvesting techniques. Ebar just states and water harvesting techniques bur sai jabo.